During the years prior to the Second World War, Germany transformed its civil industry into a military gear that not only fabricated weapons, but also new forms of destruction. Under a centralized planning, factories, engineers and ministries worked together to produce engines, armors and aircraft with a rapidity that changed the scale of the conflict. In places like Peenemünde, the tests of rockets marked the beginning of a technology that surpassed the known limits. At the same time, companies like Krupp, Porsche and Henschel designed tanks, airplanes and impossible machines, each one bigger or faster than the previous one. From those laboratories and hangars emerged projects that astonished and terrified the world, some real, others barely dreamed. All formed part of the attempt to create the most advanced army of its time, but which were those 20 vehicles that, together, changed forever the history of war. Porsche, Type 64, the origin in aluminum of the sports myth. It was built with the intention of participating in the resistance test of 1,500 kilometers that would be celebrated in September of that year. The commission was born from the relationship that the company maintained with the project of the KDF-Wagen, the so-called car of the people that later would transform into the Volkswagen Beetle. While the factory was organizing for that production, Porsche and his team received freedom to experiment with a sports vehicle capable of reaching unprecedented speeds on the road. The starting point was to take advantage of the mechanical base of the KDF-Wagen, although with a totally new bodywork. The engineers chose aluminum as the main material and resorted to fabrication techniques that proceeded from the aeronautical industry. The result was a body of very smooth lines, with the wheel arches covered by detachable panels that reduced the turbulence. The elongated shape and the curved rear part allowed to improve the aerodynamic penetration, an innovation that in that era had no equivalent. It was an automobile thought to resist long distances with a stability that recalled the competition models. The engine was placed in the posterior part to improve the distribution of weight. It was a block of 4 opposed cylinders and air-cooled with a displacement of 985 cubic centimeters, the same employed in the KDF-Wagen, although adjusted to perform better. Thanks to a change in the relation of the rear axle, of one with 345 instead of one with 447, the car could reach up to 173 kilometers per hour at 4,000 revolutions. The power was around 32 horses, sufficient to move an extremely light structure. With that performance, the Type 64 was prepared to compete in the route between the two capitals, but the outbreak of the war cancelled the race before the cars arrived at the starting line. Only 3 units were fabricated. The first was completed in 1939 and was lost shortly after in an accident. The other 2 remained under custody of the German labor organization, which had partially financed the project. One of them was utilized by the Porsche family during the following years, and the other remained stored in the workshops. The war impeded any additional development, but the design was maintained as a reference in the company's archives. The profile of the Type 64, its posterior engine and its light bodywork, established the base on which later the 356 would be built, considered the first official model of the Porsche brand. Upon finishing the war, the workshops of the company were in ruins, and Ferdinand Porsche was detained by the Allied authorities. His son Ferry, who had worked on the original project, decided to recover one of the damaged chassis. In 1947, he contacted the Italian designer Giovanni Battista Pininfarina to reconstruct the body of the vehicle. The work was realized in Gmünd, Austria, where Ferry Porsche installed a small provisional factory. The original engine was repaired and was reinstalled in the restored structure, while Pininfarina returned to the automobile the metallic shape and the details of the initial model. According to the testimonies of the era, Ferry himself placed the emblem with his surname on the hood, a gesture that would mark the beginning of the definitive logo of the company. Focke-Wulf Triebflugel, the fighter that rotated on itself. The concept did not emerge from nothing. In 1938, the engineer Otto Muck had registered a patent for a vertical takeoff airplane. Years later, the Professor Kurt Tank, responsible for the design division of Focke-Wulf, retook the idea together with the Dr. Heinz von Harlem, giving shape to a proposal completely distinct from conventional airplanes. Instead of fixed wings, the Triebflugel would have 3 large rotating blades that served at the same time as propeller and as main engine. These blades were situated around the central fuselage and were propelled by means of reaction engines installed at their ends. Each one of those wings carried at its tip a Pabst ramjet. As these engines could not function at low speed, Walter support rockets were used to initiate the rotation. When the air reached sufficient speed, the ramjets began to operate and the rockets turned off. The angle of the blades could be modified to control the speed and the flight altitude. The fuel was stored in tanks inside the fuselage and was distributed towards the three engines through ducts that traversed the central ring. The assembly rotated freely, which eliminated the torque reaction and allowed a stable rotation. The general design was of aluminum and had a cylindrical shape, with the cabin in the front part and a tail section in the shape of a cross that served as a control surface. Behind the pilot were found the ammunition compartments and the main fuel tank. At the posterior end was installed a central support wheel, complemented by 4 small wheels at the tips of the cruciform rudder. These were covered during the flight to reduce the air resistance. The system allowed to maintain the vertical position on the ground and to rotate on its axis before lifting off, a maneuver that did not resemble that of any other contemporary airplane. The planned armament included 2 Mk-103 cannons of 30 mm with 100 projectiles and 2 Mg-151 of 20 mm with 250 shots. They were mounted under the cabin and pointed at a slight downward angle with respect to the fuselage axis. The position of the pilot, seated very close to the nose, offered good frontal visibility, but no visual control towards the back, a detail that would make the landing maneuver extremely dangerous. To descend, he had to reduce the power of the engines until the structure was again in a vertical position, with the rotor rotating over the ground. The estimations of the era calculated that the Triebflugel could reach 1,000 km per hour, although only a scale model was ever built for tests in a wind tunnel. The trials demonstrated that it could approach Mach 0,9, which confirmed its potential speed. Despite the theoretical results, its construction never materialized. The Allied advance in 1945 and the lack of materials made it impossible to fabricate a functional prototype. Dornier Do 335 Pfeil, the double-propeller fastest of the Third Reich. The Dornier Do 335, known as Pfeil or Arrow, was one of the most singular airplanes that the Luftwaffe built. Its structure carried 2 engines placed in line, one at the front and another behind, which gave it a speed and stability out of the ordinary. Thanks to that arrangement, the apparatus could surpass 760 km per hour, something unthinkable for an airplane with propellers of its era. The origin of this project goes back to the ideas of Claudius Dornier, who in 1937 had patented the system of inline engines. In the years prior to the war, Dornier applied it to hydroplanes and experimental bombers, but it was in 1942 when the German Air Ministry approved its use in a long-range fighter. The first proposal, called P231, was presented as a fast bomber, but afterwards it was transformed into a multi-purpose model. In January of 1943 began the construction of the first prototype, Do 335 V1, which realized its initial flight on the 26th of October of that same year under the command of the pilot Hans Dieterle. The response was positive. The airplane showed itself to be stable, fast and with good maneuverability, although the landing gear proved to be fragile and required modifications before the following tests. The fuselage measured almost 14 meters long and its total loaded weight surpassed 9 tons. The arrangement of the engines near the central axis reduced the torque and improved the response when turning, allowing to maintain control even with a single operative engine. The wings in a low position had a wingspan of 13 meters and an area of almost 40 square meters. In case of emergency, the pilot had available a pneumatic ejectable seat, a novelty for its era, accompanied by a system of explosive bolts that detached the rear propeller and the vertical fin before the ejection. This mechanism avoided the pilot from colliding with the posterior engine when abandoning the cabin. During 1944 were completed several test versions. The models V2 and V3 incorporated improvements in aerodynamics and more powerful DB603G engines, capable of generating 1,900 horses on takeoff. With these modifications, the Do 335 reached altitudes of 8,000 meters in less than 15 minutes. The flight reports described it as a docile airplane, without a tendency to enter a stall, and with an exceptional acceleration. Its main armament included an Mk-103 cannon of 30mm mounted on the axis of the front engine, and two Mg-151 cannons of 20mm on the hood, in addition to the capacity to transport up to 500 kilos of internal bombs. The first units of the Do 335 were fabricated in the middle of the war, but the Allied bombings forced to stop the production. Barely some 40 aircraft managed to be completed before the American troops occupied the factories and took several examples. One of them ended up in the hands of the American Navy and years later was restored in Germany. Today it can be seen in the Smithsonian Museum, the only Do 335 that managed to survive. Messerschmitt Me 262, the metallic roar of the first combat jet. The Messerschmitt Me 262 was the first operative fighter airplane propelled by reaction engines. Its development began before the war, when the engineer Hans von Ohain presented the first functional models of gas turbines. In 1938, the firm Messerschmitt received the order from the German Air Ministry to create an airplane that would surpass in speed any propeller apparatus. The project, initially denominated P1065, took shape under the direction of Willy Messerschmitt, who proposed a metallic fuselage with two engines hung under the wings. The prototype was planned for 1941, but the advances were slower than expected due to the lack of adequate materials for the turbines. The first example, designated ME-262V1, flew on the 18th of April of 1941 with a provisional piston engine Junkers Jumo 210, since the reactors were not yet ready. The flight with jet propulsion was achieved on the 18th of July of 1942, using two Junkers Jumo 004A engines. That day, the pilot Fritz Wendel reached a speed of 540 kilometers per hour, confirming that the concept was viable. However, the engines were unstable and lasted only some 25 hours of service before needing replacement. The lack of heat-resistant alloys forced the use of softer materials, which reduced the useful life of the turbines. In 1943, Adolf Hitler ordered that the Me-262 be adapted as a fast bomber, capable of attacking terrestrial targets in addition to serving as a fighter. This decision delayed its entry into combat, as the engineers had to modify the design to include bomb supports under the fuselage. The resulting prototype, known as Me-262A2 Sturmvogel, could transport 500 kilos of explosive charge, although its maneuverability diminished. Despite these adaptations, the Luftwaffe insisted that its main function as a fighter should be maintained. The definitive model, Me-262A1 Schwalbe, conserved four Mk-108 cannons of 30mm in the nose and reached 870 km per hour, an unreachable figure for the Allied airplanes. The official tests began in Lechfeld, where the test pilot Adolf Galland highlighted its capacity to accelerate without effort. The airplane could climb to 12,000 meters of altitude in a few minutes, but it required long and clean runways to take off, which made it vulnerable during the ascent. In July of 1944, the experimental unit Commando Nowotny received the first operative examples. From bases in the north of Germany, they attacked formations of American bombers with tactics of pure speed. They passed between the B-17s and disappeared before being reached. Its power was impressive, but its autonomy and reliability continued to be limited. Each Jumo 004B engine generated 890 kilos of thrust, but could only function correctly at medium regime. The mechanical failures were common, and many airplanes were lost due to fires on takeoff. Even so, the experienced pilots managed to shoot down more than 150 enemy airplanes in less than a year. In March of 1945, Galland organized the unit JV-44, known as Squadron of the Knights, composed of the best available pilots. They operated from Munich-Riem and covered the retreat of the German troops with rapid attacks against Allied formations. Galland himself flew several combats in an Me-262 until the last days of the war. The Me-262 was an airplane ahead of its time. It measured something more than 10 meters, and its wings in a light sweep gave it a unique silhouette. Its pressurized cabin and the gyroscopic firing system offered an uncommon precision in the era. Although more than 1,000 units were fabricated, only a few entered into combat before the war ended. Several examples were captured by the Allies and used for tests. Its design inspired the first jets of the post-war and marked the true beginning of reaction aviation. Landkreuzer P1000 Ratte, the monster that never rolled. The Landkreuzer P1000 Ratte was the most disproportionate tank project conceived by Nazi Germany. The proposal emerged in 1942 from the firm Krupp, when its engineer Edward Grote presented to the Ministry of Armament the plans for a terrestrial vehicle of 1,000 tons of total weight. The design intended to take to the extreme the idea of an invulnerable combat car, armed like a warship and capable of sustaining prolonged confrontations against fortifications or mechanized units. The scheme included a chassis of 35 meters long, more than 14 wide, and a height superior to 11. The armor was projected with thicknesses that went from 200 to 360 thousandths of a meter, a figure that in that era widely surpassed any existing model. The prototype was to mount the same naval turret that the cruisers of the Scharnhorst class used, equipped with 2 cannons of 280mm SKC/34. For additional defense was foreseen a secondary weapon of 128mm, together with multiple automatic anti-aircraft cannons distributed over the hull. Its power plant would be mixed: 2 submarine diesel engines, MAN Phi 12Z32/44, each with 8,500 horses of force, or an alternative configuration with 8 Daimler-Benz MB 501 engines of 2,000 horses. The assembly had to generate a total close to 16,000 horses, sufficient to reach estimated speeds of 30 to 40 kilometers per hour on firm terrain. On paper, the autonomy was calculated at 190 kilometers with the tanks full. The vehicle was thought to transport a crew superior to 20 people. It would have a command compartment at the front, zones for munitions, an internal mechanical workshop, electric generators, and a large-scale ventilation system. Its weight, however, converted the project into a fantasy. The pressure on the ground was so high that no European bridge could support it, and its displacement would destroy roads and civil structures. Furthermore, the fuel consumption would have exhausted the resources of any armored unit in a matter of hours. Despite these evident limitations, Adolf Hitler showed personal interest in the concept. He ordered Albert Speer, Minister of Armament, to study its viability together with the plan for an even larger tank, the Landkreuzer P1500 Monster. In 1943, after reviewing the technical reports, Speer cancelled the complete program. He considered that diverting materials and time towards such an enormous machine was a loss of resources that the country could no longer afford. At that moment, the production of armoured vehicles was concentrated on the Panzer IV, the Panther and the Tiger, models with real tactical value. The idea of Grote also included equipping the Ratte with a long-range radio station, an auxiliary generator and a small reconnaissance vehicle stored in the rear part. The design detailed tracks of 3 meters wide, formed by links that weighed hundreds of kilos each. To maneuver, the system required a double differential turn, similar to that of heavy naval carriages. Its armor, although theoretically impenetrable, converted it into an ideal target for enemy aviation. The construction would have needed specialized shipyards, the same ones that produced submarines, since no tank factory could house such a structure. The calculations showed that the assembly would demand tens of thousands of tons of steel and a logistical process comparable to that of a battleship. The size impeded railway transport, which meant that it had to be fabricated and operated within a specific zone without possibility of transfer. Had it been built, it could only move by its own power in a limited area and would be visible from great distances, annulling any possibility of surprise or camouflage. After the official cancellation in 1943, the plans were archived and later discovered by the Allies at the end of the war in the warehouses of Krupp, near Essen. Those documents confirmed the exact dimensions of the model and the power calculations, which coincided with the reports from the Ministry of Armament. No physical remains nor fabricated components exist. Everything remained in the design stage. The project was later studied as an example of the industrial excesses of the Third Reich, when the war strategy was already in decline and the country was seeking impossible weapons to compensate for the imminent defeat. Fieseler Fi 103R Reichenberg, the bomb that carried a pilot. The Fieseler Fi 103R Reichenberg was the manned version of the V-1 flying bomb, an attempt to convert a weapon without control into an apparatus guided by a pilot. The project was developed within the Kampfgeschwader 200 in the squadron called Leonidas Staffel, whose volunteers signed a declaration admitting the almost certain death in the mission. After discarding the Me-328 for engine problems, Otto Skorzeny and the test pilot Hanna Reich pushed for the adaptation of the Fi-103, adding a cabin in the bow, so that a man could guide it to the target. The name Reichenberg was taken from the capital of the old German territory of the Sudetenland, today Liberec. The fabrication was assigned to the DFS, the German Research Institute for Glider Flight, situated in Einring. In barely 2 weeks, the engineers presented 3 prototypes ready for the first trials. The conversion of the V1 consisted of installing a tiny cabin just in front of the air intake of the Argus AS-014 pulse jet. Inside there was a wooden seat, basic flight controls and a single-piece windshield. The cylinders of the automatic pilot were removed, and a single tank of compressed air was placed in the rear part. The design also incorporated metallic edges on the wings to cut cables of barrage balloons and improvised protection against the British defence. In October of 1944, there already existed 4 variants. The RI was a glider without an engine, the R2 a training model with a double cabin, the R3 with a false nozzle, and the R4 the motorised standard. Each one was used for different phases of instruction. The operative plan foresaw that the Reichenbergs would be transported by Heinkel He-111 bombers and released near the target. The pilots would have to direct them towards the objective and jump with a parachute just before the impact. In theory it seemed possible, but the reality was another. The position of the pilot, situated a few centimeters from the reactor's intake, made it almost impossible to escape with life. The probabilities of survival were less than 1%. The tests began in September of 1944 at the base of Lats. In the first flight, a Reichenberg launched from a He-111 crashed after losing the canopy of the cabin. The second attempt had the same result. Even so, the test pilots Heinz Kenscher and Hanna Reich continued the experiments. Reich suffered several light accidents, while Kenscher managed to jump in a parachute when one of the wings detached in mid-flight. During that same period, the volunteers of the squadron trained with ordinary gliders to learn to control descents without an engine, and afterwards they moved on to the R2 models of double control. The landings were complicated and were realized on a skid, since the machines were not designed to be reused. On the 5th of March of 1945, Heinz Kenscher died during a new test with a modified model, when both wings separated from the fuselage. His death led the commander Werner Baumbach, chief of the KG-200, to ask Albert Speer to intervene. Speer, who already opposed the suicide missions, organized a meeting with Hitler on the 15th of March. He argued that that type of operations did not form part of the German military tradition and convinced the Führer to stop the program. That same day, Baumbach ordered the definitive dissolution of the Leonidas-Staffel. At that moment, there existed 60 trained pilots and some 175 apparatuses ready for combat, none of which ever flew on a real mission. The Allies found several intact examples in the hangars of northern Germany, silent witnesses of an experiment that took war desperation to the extreme of placing a human being inside a bomb. Messerschmitt Me 323 Gigant, the giant transport that could not escape. The Me 323 was the largest transport airplane fabricated by Germany. It emerged from the glider Me 321, created to move troops and heavy vehicles. Although the planned invasion of Great Britain was never realized, the project continued when the Eastern Front demanded to transfer material over long distances. In 1941, it was decided to transform the glider into a motorized model capable of taking off by itself. Thus was born the Me 323, known by its crews as Gigant, the Giant. To alleviate the German production overloaded by the war, French radial engines Gnome Aeron GR14N of 1,160 horses of force were chosen. The first trials were realized with 4 engines, but the power resulted insufficient. The airplane barely reached 210 kilometers per hour, too little for such a large transport. It was opted then for a configuration of 6 engines distributed along the wings, with 3 rotating to the left and 3 to the right to compensate the torque. That definitive version became the D model with which the operations would begin. The structure was built with a combination of metal, wood and fabric to save aluminum. The wings were semi-supported and were reinforced with wooden spars, while the fuselage was formed with metallic tubes covered with doped fabric. The internal floor was reinforced to support up to 12 tons of cargo. The main compartment measured 11 meters long by 3 wide and 3,4 high, sufficient to transport a heavy cannon of 150 millimeters with its tractor vehicle, 2 trucks, an anti-aircraft cannon of 88 millimeters or more than 100 soldiers. In medical configurations, it could carry 60 stretchers. The habitual crew was composed of 2 pilots, 2 flight engineers and a radio operator. The engineers controlled the synchronization of the engines from small cabins situated inside the wings, which allowed the pilots to concentrate on navigation. If necessary, 2 gunners could be added. The airplane had 5 heavy machine guns, MG-131 of 13 millimeters for defense, with positions in the rear part and the sides. Its fixed landing gear, formed by 4 front wheels and 6 rear wheels in parallel, could stop the aircraft in barely 200 meters of runway thanks to pneumatic brakes. The first flight of the 6-engine model was realized at the beginning of 1942. At the end of that year, the Me-323 began to operate in the Mediterranean, where the losses of maritime transport of the Axis forced to resort to the air to supply the forces of Rommel in the north of Africa. The Gigants transported fuel, weapons and provisions from Italy to Tunisia, crossing a sea full of Allied fighters. In April of 1943, a formation of 27 loaded apparatuses was intercepted between Sicily and Tunisia by squadrons of Spitfire and P-40. 16 of them were shot down in a few minutes, converting the event into one of the biggest aerial transport disasters of the war. Despite this, the airplane continued in service until 1944. The Me-323 reached only 219 kilometers per hour at low altitude, and its effective range, with full cargo, was of some 1,200 kilometers. There were proposals to equip it with more powerful BMW 801 engines, but they never materialized. A total of 198 units were built, including D and E variants, which incorporated structural improvements, greater fuel capacity and reinforcements in the defensive armament. There even existed an armed prototype, the Me-323WT, thought to escort other transports, with 20 cannons and a crew of 21 men, although it was cancelled upon verifying its ineffectiveness. At the end of the war, no complete example remained. However, in 2012, Italian divers found the remains of an Me-323 off the island of La Maddalena in Sardinia at 60 meters of depth. The airplane had been shot down on the 26th of July of 1943 by a British Bristol Beaufighter fighter while it was flying towards the north of Italy. Blohm Voss BV-141, the glass cabin that defied logic. The Blohm Voss BV-141 was a tactical reconnaissance airplane with a design so unusual that it seemed impossible. The engineer Richard Vogt created it to offer the pilot total visibility, something that conventional models did not achieve. Instead of a centered cabin, it had a glazed gondola to one side of the fuselage, joined by an asymmetrical wing. Despite its unbalanced appearance, the airplane flew in a stable manner and demonstrated that German aerodynamics could defy all logic. The final design had a main fuselage on the left, with a BMW radial engine of 600 horses of power in the frontal part, and a glazed gondola to the right of the central axis, joined by a wing of uncommon arrangement. In that lateral cabin were located 3 crew members, pilot, radio operator and gunner. From there was obtained a panoramic view of almost the entire environment, something unprecedented for its time. The airplane seemed to have a sidecar attached to a wing, which generated doubts among the engineers of other companies about how it would manage to maintain balance in flight. Against all odds, the first trials demonstrated that the BV-141 was stable and maneuverable. The first prototype flew on the 25th of February of 1938, and although the behavior was correct, the initial engine soon revealed itself to be insufficient. That lack of power led the Luftwaffe to favor a rival design, the Focke-Wulf FW-189, of a more traditional configuration with a double engine and central cabin. Even so, Vogt continued the development and created a new, more powerful version, the BV-141B, equipped with a BMW 801 engine of more than 1,500 horses, reinforced fuselage and better defensive armament. With those improvements, the airplane reached speeds superior to 480 kilometers per hour, equaling or even surpassing in performance contemporary reconnaissance models. 23 units were built, of which some 20 were delivered officially. Although it was never produced in series, some examples were used in real missions over the Eastern Front between 1941 and 1943. The flight reports confirmed its good stability, but the production was limited by the scarcity of resources and the preference of the High Command for already established aircraft. The BV-141 had a crew of 3 people, an empty weight of 4.5 tons and a total load superior to 6. Its cruise speed was around 430 kilometers per hour, and its autonomy surpassed 1,800 kilometers. It was a resistant airplane thought for prolonged flights of observation and tactical reconnaissance. Its structure, made in large part of aluminum, combined a low monoplane wing and an off-center tail that balanced the weight of the lateral gondola. The result was an efficient machine, despite its strange appearance. Throughout 1942, its performance was evaluated on different fronts. Its performance was technically correct, but the German Air Ministry decided to close the program in 1943, considering that its production would complicate even more the logistics of the industry. The remaining examples were used as liaison and test airplanes before being retired. None survived the end of the war. Focke-Wulf Fa 330 Bachstelze, the eye of the submarine. The project was developed by the engineer Heinrich Focke, founder of the company Focke-Wulf Flugzeugbau, with the support of the group Weser Flugzeugwerke. His goal was to build a detachable apparatus, resistant and small enough to be stored in sealed containers on the deck of the submarine. The entire assembly weighed barely 80 kilos and could support a load of more than 300. It had a seat for the pilot, a compass, a tachometer, and a telephone that kept him in direct contact with the commander of the submarine. The Fa 330 was assembled on the deck by 2 sailors and was joined to the U-boat by means of a steel cable of some 150 meters. As the submarine advanced on the surface, the flow of the air made the 3 blades of the rotor turn, elevating the apparatus with its observer on board up to some 120 meters of altitude. From that position, the operator, provided with binoculars, could see up to 40 or 45 kilometers of distance, a range almost 5 times superior to that which was obtained from the command tower of the submarine. To retrieve it, the crew used a winch that wound the cable slowly, stopping the rotor with a brake once the apparatus touched the deck. Its structure was of lightweight steel tubes with a central pylon that supported the main rotor. The system had no engine. The rotation of the blades depended on the wind and the speed of the submarine. The takeoff could be done even with a gentle wind by manually turning the rotor. In case of emergency, the pilot had a mechanism to detach the set of blades, automatically deploying a parachute that returned him to the water in a safe manner. Nearly 200 examples were built, fabricated in Delmenhorst by Weser Flugzeugwerke. The complete operation of assembly, use and disassembly could take some 20 minutes, and although the apparatus resulted stable in the air, its employment was not exempt from risk. If the submarine was attacked during a patrol, the pilot ran the danger of being abandoned, as the captains often could not wait for his recovery before performing an emergency dive. The Fa 330 was used above all in the German submarines that patrolled the South Atlantic and the Indian Ocean, where the danger from the air was lesser. In those missions, the small autogyro served as the eyes of the submarine, elevating its observer above the sea to detect distant ships. Its most remembered use occurred in 1943, when it allowed to locate an enemy freighter that ended up sunk a few hours later. Later, when one of these apparatuses was captured intact, the British tested it and confirmed its efficacy, although the advance of helicopters made it obsolete. Inside the submarines, the Fa 330 was stored in sealed compartments, and its assembly demanded precision. The sailors knew that flying it was risky. If the submarine had to submerge in an emergency, the pilot was left abandoned. For that reason, it was only used in quiet zones, far from the reach of Allied airplanes. With time, it was proven that, although the Fa 330 served to watch the sea, its deployment was slow and dangerous. Many submarines were discovered while using it, and the program was cancelled in 1944. Its history remained as a rarity, a small autogyro that gave the German submarines a brief but ingenious view from the sky. V-2 rocket train, the Railroad of Terror. Germany devised a way to keep its V-2 rocket program active without depending on permanent bases. It transferred the entire launch system to mobile platforms hidden in forests and railway tunnels. Thus was born the V-2 rocket launcher train, a complete installation on rails capable of moving and attacking from different points without leaving a trace. The convoy was formed by several camouflaged wagons with technical personnel and all the necessary equipment: fuel, liquid oxygen, generators and the components of the missile. One of the cars served as a control center and another as a workshop. The rocket, of more than 14 meters in height, was mounted vertically on an adapted platform that allowed to prepare and launch it without a fixed base. These trains were operated by the personnel of the artillery divisions of the army, in coordination with the TOT organization and technicians coming from Peenemünde, the original development center of the project. The production and logistics were directed by General Hans Kammler, responsible also for the subterranean installations where the rockets were assembled. His objective was to guarantee that the missiles could be fired from any point in Western Europe with rapidity and without exposure to Allied aerial reconnaissance. The railway system offered a clear advantage: mobility. The convoys could move at night, stop in abandoned stations or use secondary branches. In a matter of hours, the train transformed into an operative launcher. The preparation team was deployed next to the convoy and performed the final adjustments before ignition. After the shot, the train could withdraw almost immediately, leaving only a small circle of burned terrain as a trace. This made it extremely difficult for the Allies to locate and destroy the launch points. Each unit had approximately 120 men. The operations were directed from an armored command wagon that included radio and calculation systems for the trajectories. The rockets were transported in a horizontal position and before the launch were elevated by means of a hydraulic device. The complexity of the process demanded discipline and precision, since a failure in the handling of the fuel or a leak of oxygen could provoke an explosion. At the end of 1944, several trains of this type were operating in Belgium, the Netherlands, and the north of Germany. They were used principally to attack London and Antwerp, taking advantage of the possibility of moving quickly before being detected. Each convoy carried between 3 and 5 rockets and could prepare a shot in less than 2 hours. The routes were planned in advance, and many sections were conditioned specially to resist the weight of the loaded wagons. After the German surrender, some of these trains were left abandoned in tunnels or hidden stations. One of the most notable findings occurred in the Belgian Ardennes, where a complete convoy was found intact inside a railway tunnel. In its interior, there were remains of rockets, measurement equipment, and deposits of frozen fuel. The Allied forces studied the finding in detail to understand how Germany had managed to adapt such a complex launch system to a mobile infrastructure. The Allied reports concluded that the launcher train was one of the most ingenious solutions of the V2 program, although its real impact was limited by the scarcity of resources and fuel. As the Allied troops advanced towards the interior of Germany, the system lost utility, and many convoys were destroyed by their own crews to avoid capture. The recovered remains were transferred to research centers in the United States and the United Kingdom, where they served as a base for future studies on military logistics and medium-range missiles. Today, only some remains are left: twisted rails, metallic pieces, and a recovered wagon in Belgium. The V2 launcher train was a mobile launch base, hidden between forests and tunnels, capable of firing and disappearing without leaving a trace. Borgward IV, the remote-controlled tank. The project emerged in 1940, when the Borgward Company received the commission to fabricate an armored support vehicle for combat engineers. The initial idea was to use it as a munitions carrier, but soon its potential as a remote demolition weapon was seen. The engineers adapted the chassis to include a frontal compartment that housed an explosive charge of 500 kilograms attached to an inclined ramp. The vehicle could approach the target, drop the bomb, and return before the detonation occurred, which was activated remotely from a control tank situated several hundred meters away. The Borgward IV measured around 4 meters long and 1 with 80 wide. It weighed between 3 and 5 tons, according to the version. The structure was divided into 3 sections. At the front was found the transmission with a hydraulic gearbox of 2 speeds. In the center, the driver's compartment, and in the rear part, the Borgward gasoline engine of 6 cylinders, the fuel tanks, the radio, and the actuation system of the explosive compartment. Its autonomy was of some 150 kilometers, with a maximum speed close to 38 kilometers per hour. The control of the vehicle was realized in 2 ways. During the initial advance, a driver guided it manually until approaching the objective. Then he abandoned the tank, and the control passed to a remote operator who handled the Borgward IV by means of radio signals from an adapted tank, first a Panzer III and later a Stug III or a Tiger I. From that position, the operator could drive the vehicle, release the charge and withdraw it before the explosion. This system made it more versatile than the cable-controlled models, which used to be destroyed after each use. The series production began in 1942 and was developed in 3 main versions, Ausführung A, B and C. The A model was the first to be fabricated, with an engine of 49 horses of force and armour of 8 mm. Between May of 1942 and June of 1943, 616 units were built. The Ausf B, produced between June and November of 1943, incorporated a better radio and greater weight. The Ausf C, fabricated from December of 1943 until September of 1944, presented a longer chassis, a new engine of 78 horses, and a reinforced protection of 20 mm on the sides and the front. In total, 1,181 vehicles were built. In addition to its original function, some Borgward IV were modified at the end of the war. A small number were transformed into improvised tank destroyers, known as Panzerjäger, equipped with launchers for anti-tank rockets RPZ-B-54/1. These versions participated in the urban combats during the Battle of Berlin in 1945. Other experiments included an amphibious prototype and a vehicle equipped with a television camera for remote observation, one of the first attempts at visual transmission from a combat vehicle. The Borgward IV was employed by the tank battalions 301 and 302 of the Wehrmacht. In the Battle of Kursk, it was used principally to clear minefields and destroy fortifications. However, its effectiveness was limited. The light armor made it vulnerable to anti-tank rifles, and its size converted it into an easy target. Furthermore, the radio signal could be interfered with or lost, which at times provoked the loss of the vehicle before fulfilling its mission. Even so, its design showed a notable technical advance. It had an electronic decoder, a detonation relay, and a self-destruction system to avoid capture. At the end of the war, several examples were captured by the Red Army and analyzed in Kubinka. The Soviets called them teletanks and studied their design to create their own defenses. Some were preserved in museums, and decades later one appeared buried in Vienna, where it was restored. The Borgward IV did not have success in combat, but it marked a first attempt to control a vehicle at a distance. Its technology anticipated the idea of automated weapons long before the world was ready for them. Type 21 Electroboot, the submarine of the future. The Type 21, known as Electroboot or electric boat, was the most advanced submarine that Germany came to build. It was the first thought to operate for long periods under the water, not only to hide momentarily. Its development changed the idea of submarine warfare, although it arrived too late to influence the final result. The construction began in 1943 with a completely new design, a more hydrodynamic hull, expanded batteries and powerful electric motors. Thanks to that, it could move faster submerged than on the surface, something never seen until then. The hull was molded to reduce resistance and improve performance. Equipped with a snorkel, it could recharge its batteries at periscope depth without emerging completely. Thanks to this, it could navigate at more than 5 knots for more than 70 hours straight and recharge in less than 5, which converted it into a constant and invisible threat. Furthermore, its propulsion system was much quieter than that of the previous models, which complicated its detection by Allied radars. The armament also represented an important technical leap. It had 6 torpedo tubes in the bow, instead of the 4 habitual ones, and an electric reloading system that allowed it to fire 18 torpedoes in less than 20 minutes. It also incorporated a sonar of great sensitivity installed under the frontal part of the hull, which increased its capacity to detect targets with precision. Its interior offered a level of comfort unusual for the era. Wider cabins, better ventilation systems, and a refrigerated compartment to conserve food during prolonged patrols. However, its hurried development and the lack of quality materials generated multiple failures. The factories that produced the prefabricated sections, 9 for each submarine, lacked experience in naval construction, which caused cracks, assembly errors and leaks. Although 118 units were completed between 1943 and 1945, only 4 were ready to operate before the end of the conflict, and only 2 performed real patrols. The U-2511 and U-3008. None of them managed to sink enemy ships. The original plan was to assemble the submarines in the enormous bunkers of the port of Farge, near Bremen. That installation, known as the Valentine Bunker, was built with the forced labor of thousands of prisoners, but it never came to function fully. In March of 1945, the Allied bombings destroyed a large part of the complex, and shortly after it was occupied by British troops. After the surrender, the Allies divided the Type 21 submarines among themselves. Each power studied them and adapted them to its own technology. In them they found the base for the new designs of the post-war. More aerodynamic hulls, greater autonomy under the water and silent engines. One of the few that survived was the U-2540, refloated and converted into a floating museum in Germany. Although the Type 21 arrived late to change the war, it transformed forever the way of building submarines and marked the beginning of the modern era under the sea. Sd.Kfz.2 Kettenkrad, the motorcycle track. The Kettenkrad was a singular vehicle, half motorcycle, half track. Light and resistant, it could move through mud, snow or ice when other vehicles were stuck. It served to drag cargo, carry personnel, or open a path on the front. Its development began in 1939, when the engineer Heinrich Ernst Kniepkamp patented a motorcycle with tracks. Shortly after, the NSU Motorenwerke factory received the order to produce it as a light tractor, capable of travelling even in the hold of an airplane to accompany the airborne troops. The result was a design without precedence. In the front part it conserved a fork and a motorcycle wheel, while in the rear part it incorporated a track system with 6 wheels per side. Its compact form allowed it to move in terrains where trucks got stuck. The engine of 4 cylinders and 1,488 cubic centimetres, proceeding from the Opel Olympia automobile, delivered 36 horses of power, sufficient to move its 1,300 kilos of weight and reach 70 kilometers per hour on the road. The driving combined the handlebar of a motorcycle with the control of a track. Turning the handlebar directed the front wheel, but by forcing the turn more, the brakes of the tracks were activated to facilitate tight maneuvers. This system allowed a surprising control even on slopes of 45%, or when fording rivers of almost half a metre of depth. It could tow up to 450 kilos and drag light pieces of artillery or supplies. The first 70 units were delivered to the Wehrmacht in 1940 for field tests. Quickly failures were detected in the front fork, taken from an NSU motorcycle of 600 cubic centimetres, which broke with ease on irregular terrains. From 1942, it was substituted by a reinforced fork with hydraulic shock absorbers, which notably improved the resistance. In combat, the Kettenkrad debuted during the invasion of Crete in 1941 in Operation Mercury. Shortly after, it was sent to the north of Africa with the Africa Corps, and later it served on the fronts of Italy, Yugoslavia and the Soviet Union. Its reduced size made it ideal for transport in airplanes or gliders, and on the terrain it could advance where neither trucks nor medium-armoured vehicles managed to do so. Despite its utility, the vehicle had several inconveniences. Its consumption was high, similar to that of a small tank, which was problematic when the scarcity of gasoline worsened. It was also complicated to drive and even more difficult to repair. The front brakes, situated next to the steering mechanism, used to fill with oil and required constant maintenance. Furthermore, the reverse gear presented structural weakness, and the transmission, complex and expensive, could suffer damage if a wheel got stuck. Even with those limitations, the soldiers valued its performance highly. It was reliable, fast and capable of operating in extreme conditions. The Wehrmacht used it in multiple tasks, as a tow for anti-tank cannons, a communications vehicle, transport of cabling and a light scout. There also existed special versions, such as the Sd.Kfz.2 2/1 and 2/2, designed to lay communication cables during combat. Between 1940 and 1944, around 8,345 units were fabricated in the NSU plant in Neckarsulm. When the German defeat was already imminent, the command ordered to stop its production. However, after the war, the same factory received Allied authorization to build 550 civil units adapted for agricultural work. The later versions were used in crop fields during the German reconstruction. Their traction and power made them ideal for moving machinery, transporting supplies, and ploughing difficult terrains in a devastated country. The production ceased in 1949, although many remained active until the end of the 1950s decade. Volkswagen Schwimmwagen, the amphibious car. The Volkswagen Type 166, known as Schwimmwagen, was an amphibious vehicle that united the agility of an all-terrain vehicle with the buoyancy of a small boat. Designed by Ferdinand Porsche, it became the model of its type most produced in history, with more than 15,000 units between 1942 and 1944. The project emerged after the success of the Kugelwagen, when the German army asked for a version capable of crossing rivers, swamps and unstable terrains. The engineer Erwin Kommender designed a sealed body in the shape of a hull and a shorter and more resistant chassis, which gave it firmness on land and stable flotation in the water. The first prototype, called Type 128, was tested in 1940 and proved to have little resistance off-road. The deformations of the hull made it insecure. From those tests was developed the Type 166, with a more compact, light and solid bodywork. The fabrication was divided between the main plant of Volkswagen in Fallersleben and the Porsche factory in Stuttgart, while the metallic bodies were produced by Astonished in Berlin. The vehicle had a boxer engine of 4 cylinders and 1,131 cubic centimeters, air-cooled, that generated 25 horses of force. It weighed around 900 kilos and could reach 80 kilometers per hour on land and 10 in the water. It had all-wheel drive in first and in reverse, and ZF self-locking differentials on both axles. The reducers in the wheel hubs increased the distance to the ground and reduced the effort of the transmission. To move on the water, the Schwimmwagen incorporated a foldable propeller in the rear part, actuated directly by the crankshaft of the engine by means of a simple mechanical union. Upon lowering it, the propeller rotated with the engine, propelling the vehicle forward. It had no reverse gear in the water, but it could go backwards by turning the wheels or with the help of the oars it carried as standard equipment. The steering was maintained through the steering wheel, since the front wheels also served as a rudder. The interior was basic and functional, without luxuries or additional protections. The vehicle could transport up to 4 soldiers with armament and complete equipment. Its average consumption was of 10 litres per hour, with a tank of 50 litres that allowed to travel more than 500 kilometres on land. The spare wheel was placed on the front hood, and the sides of the vehicle were equipped with handrails to facilitate the movement of the crew in and out of the water. The field tests began in August of 1941 in mountainous regions of Austria, where Porsche himself related how the vehicle managed to climb slopes impossible for other automobiles. In 1942, it officially entered mass production. By mid-1944, more than 14,000 units had been assembled in the Volkswagen plant and some 1,300 in Stuttgart. However, the bombings on the factories of Astonished and Wolfsburg interrupted the production shortly before the end of the war. The Schwimmwagen was used principally on the Eastern Front and in reconnaissance operations, where its amphibious capacity was invaluable. It was also employed by units of engineers and light artillery to cross rivers or transport munitions in flooded zones. Its maintenance was simple, and it could operate in extreme conditions of cold or humidity. After the war, the majority of the Schwimmwagens were destroyed or dismantled. Only a few survived and are conserved in museums or private collections. More than a military vehicle, the Schwimmwagen was a display of ingenuity, a car capable of moving by land or water with the same ease. Kugelpanzer, the sphere tank. In the Museum of Kubinka, some 60 kilometers from Moscow, is found one of the most enigmatic vehicles of military history, the Kugelpanzer, known as the spherical tank. This prototype of an almost circular shape continues to be a mystery since its finding in Manchuria in August of 1945, when the Soviet troops captured it from the Japanese forces. Since then, no official documentation has been found about its origin, its manufacturer, or the exact purpose for which it was created. The vehicle, unique in its type, presents a completely closed metallic structure and a design of 3 wheels, 2 large main rollers of 1.5 meters in diameter that allow movement, and a small rear wheel that gives it stability. It weighed close to 1.5 tons and was propelled by an engine of 25 horses, which gave it an approximate speed of 30 kilometers per hour on firm terrain and something less than 10 on irregular surfaces. Its armor was of some 5 millimeters of thickness, sufficient barely to resist the fire of light arms. The driver, sole occupant, entered through a rear hatch and sat on the tank and the engine with the controls at the front. In the frontal part there was a small slit as a visor, and just below an opening that possibly served to mount a German MG-34 machine gun or a Japanese 96 LMG, although it has never been confirmed in an official manner. The purpose of the vehicle continues to be uncertain. The most accepted theory holds that it would have been conceived for observation or reconnaissance tasks, allowing its occupant to move protected near the enemy lines. Had it been so, the interior would have had a radio to transmit coordinates or artillery corrections. However, other hypotheses suggest that it could be a failed experiment or even a piece of Soviet propaganda built after the war. Among the arguments that feed the doubt are found its low speed, its scarce protection, and the total absence of technical documents. Furthermore, experts have pointed out that the welds of the vehicle are crude and of bad quality, something improper of the German industry of the era, which has led to think that it could have been a Soviet falsification mounted after the conflict. Outside of those conjectures, the only verifiable thing is the example that remains in Kubinka, recently restored and painted with its original grey colour. Its structure is so peculiar that it seems more a rolling capsule than a tank. It measured around 1.5 meters wide and another much in height, with a shape that recalled a large metallic sphere divided into two symmetrical halves. Throughout the years, different media and publications have tried to reconstruct its history. Some describe it as a German attempt to create an ultralight reconnaissance vehicle for the Japanese army, while others consider it an independent Japanese development inspired by German technology. In any case, there is no evidence that it participated in real combat, nor that more than 1 or 2 experimental units were fabricated. Its spherical design awoke curiosity from the first moment. The Kugelpanzer appeared in exhibitions and studies, but nobody managed to define with certainty its function. It was not a tank nor a reconnaissance vehicle, but a rarity of steel that reflected the confusion of the last years of the Third Reich. Today it is conserved as an enigmatic piece, testimony of an era in which the urgency to innovate surpassed any practical sense. Tatra T87, the car that killed officers. In the decade of the 30s, when Europe was approaching the conflict, Czechoslovakia produced one of the most advanced automobiles in the world, the Tatra T87. Its design was the work of the engineer Hans Ledwinka, a pioneer who had revolutionized the concept of aerodynamics applied to civil vehicles. The bodywork, created together with the stylist Erich Überlacher, was molded in wind tunnels and presented a curved line that reduced to the minimum the resistance of the air. It was a light car with a structure of steel and aluminum that gave it a futuristic aspect and a stability uncommon for its era. The engine was placed in the rear part, a V8 air-cooled made of magnesium, capable of reaching 160 km per hour, an exceptional figure for a touring car of the 30s. Its combination of power and low weight made it efficient and fast, which converted it into a symbol of prestige among the technical and industrial elites of the country. The interior was designed for comfort on long trips, with ample seats, good visibility, and a reduced consumption that surprised drivers accustomed to conventional engines. When Germany occupied Czechoslovakia in 1939, the Tatra factories were left under the control of the Reich. The German officers stationed in the region felt attracted by the T87 and began to use it as a personal car. It was fast, elegant, and of modern aspect, but it also brought with it a problem that soon became known among the troops. Its rear engine and its extreme aerodynamics generated a behavior difficult to control at high speeds, especially on narrow roads or with tight curves. Many of the military drivers, little familiarized with that type of configuration, ended up crashing. The accidents became so frequent that the vehicle acquired a disquieting reputation within the Wehrmacht. The records of the era mention several officers who lost their lives driving the T87 at full speed, which led to the phrase circulating among the troops that the Czech car killed more German officers than the partisans. The German administration ended up prohibiting its use by military personnel, an unusual decision in the case of an automobile produced within the occupied territory. Even so, the interest in the design of the Tatra did not disappear. Ferdinand Porsche, who at that time was working on the development of the Volkswagen Kugelwagen and the future Beetle, knew well the ideas of Ledwinka. Both had met years before, and the German engineer had recognized that some technical solutions of the Volkswagen came from the concepts created by Tatra. The location of the rear engine, the air cooling and the aerodynamic shape shared an evident relationship. After the war, Tatra sued Volkswagen for patent infringement, and after a long judicial process, the Czechoslovakian company received an economic compensation at the beginning of the 50s. The car continued in production for several years after the conflict. Between 1936 and 1950, a little more than 3,000 units were fabricated, many of them destined for high officials or scientists. Even explorers like the Austrian Hans Helfrich or the Czech writer Miroslav Zikmund used it in expeditions through Africa and Asia, where the air engine demonstrated a notable reliability. Its autonomy, close to 800 kilometers per tank, made it ideal for long journeys without refueling. With the years, the Tatra T87 came to be a reference of automotive design. Its aerodynamic shape influenced European sports cars and demonstrated how advanced Czechoslovakian engineering was before the war. Henschel Hs S-129, the aerial tank hunter. The Luftwaffe was looking for an airplane capable of destroying tanks from the air. From that necessity emerged the Henschel Hs 129, designed to resist enemy fire and attack the armoured vehicles directly. Its development was complicated, but it ended up being the only German model created exclusively for that task. The first prototype flew in 1939 with low-power engines, which made takeoff and maneuver difficult. Even so, its structure was resistant. The cabin was armoured with steel and thick glass, so tight that the pilot could barely move. It was a machine made to survive, not to fly with comfort. During the tests, the engineers detected several problems. The visibility was reduced, the airplane tended to be unstable, and the engines failed frequently. Henschel tried to correct them, but the start of the war interrupted the production. At the end of 1940, the Luftwaffe retook the project because it urgently needed a close support airplane. By then, the invasion of the Soviet Union had demonstrated that the T-34 and K-1 tanks were almost impossible to destroy with conventional terrestrial fire. In 1941, it was ordered to fabricate an initial series of the Hs 129B, this time equipped with more powerful French Gnome-Rhone 14M engines. The fuselage was reinforced, dive brakes were added, and the armament was improved with cannons of 20 mm and automatic cannons of 30 mm. Its new armor completely enveloped the cabin, protecting the pilot from shots from the ground. With those modifications, the airplane began to be tested on the Eastern Front, where its main function was to attack concentrations of Soviet tanks. In ideal conditions, the Hs 129 was fearsome. Its precision at low altitude and the power of its weapons allowed it to perforate the armor of a T-34 in a single impact. However, it also had serious limitations. It was slow, difficult to handle and vulnerable to enemy fighters. Many pilots nicknamed it the Flying Coffin for how complicated it was to take off with full weight and for its lack of maneuverability. Even so, the units that piloted it managed to accumulate a certain experience, especially on the fronts of Ukraine and Belarus. In 1943 appeared its most lethal version, the Hs 129B3, armed with a BK-7,5 cannon, derived from the anti-tank PK-40 of 75 mm. It was the largest weapon ever mounted on a combat airplane. Its recoil was so strong that it forced the reinforcement of the fuselage with steel supports. The cannon fired armor-piercing projectiles capable of destroying any Allied tank of the era, even at medium distance. But the power had a price. The airplane could barely maneuver after firing, and the extra weight made it even slower and clumsier. The missions with the 75 mm cannon were realized above all in the summer of 1944, when the Germans were trying to stop the Soviet advance. The crews attacked in small groups, flying at ground level and firing a single time before fleeing at low altitude. Many airplanes were lost to anti-aircraft fire or to mechanical failures. Despite its low survival rate, they managed to destroy dozens of tanks, which led the Luftwaffe to keep it in service until the end of the conflict. In total, around 850 Hs, 129 of all versions were built. Some were also used in the north of Africa, where they demonstrated their utility against light British vehicles. However, its production was never sufficient to change the course of the war. When Germany surrendered, only a few remained in condition to fly, and the majority were captured or dismantled by the Allies. The Hs 129 was an airplane as resistant as it was difficult to pilot. It sought to become an aerial tank hunter, although its mechanical failures limited its success. Even so, its design opened the way for future attack airplanes, created to strike with precision from low altitude. Schienenwulf, the track-destroying plough. The Schienenwulf, or Wolf of the Rails, was a steel wagon created to destroy railway tracks during the German retreats. It carried an enormous hook that tore out the rails and broke the sleepers as it advanced. It was also known as Schwellenpflug, the sleeper plough, for the way it lifted the track under its passage. It was developed in 1942 by the Krupp company, with support from the Deutsche Reichsbahn and the Reich Ministry of Transport. At first glance it seemed like a common wagon, but under its structure it hid a hook of almost a ton that destroyed the path in its passage, leaving the rails bent and the ground covered with remains. The Schienenwulf was coupled to a locomotive, or between two, advancing at a speed of between 7 and 10 kilometers per hour. To initiate the operation, the team of 10 men lowered the hook manually or by means of a hydraulic system until it touched the center of the track. The preparation process took barely a few minutes. Then the train started and the hook did its work, tearing everything in its path with a metallic noise that was heard at a great distance. In a matter of hours, a single group could render useless dozens of kilometers of railway. The system was surprisingly simple and very effective. The engineers' calculations indicated that, in a single pass, the Schienenwulf completely destroyed all the sleepers, between 70 and 90% of the rails, and up to a third of the metallic joints. With this, the tracks were left totally unusable. Its weight was around 30 tons, and several soldiers were needed not only to operate it, but also to protect the convoy, since many of these machines were armed with anti-aircraft machine guns to defend themselves from enemy attacks. Some versions incorporated explosives to blow up bridges or complicated sections of the line. The use of this wagon formed part of the scorched earth policy that Hitler ordered during the collapse of the Third Reich. Each time the German forces retreated, they had to destroy roads, depots, factories and communication lines to prevent the enemy from using them. Military reports showed that the use of the Schienenwulf could delay the Soviet advance by up to 3 days, the time required to repair the damaged sections. The troops used it principally in Poland, Ukraine and Italy, although there were also records of its use in the Balkans and eastern Germany. The apparatus had a simple structure, but it had variants. At least 8 different models were fabricated, some with an added metallic shield to protect the operator from fragments or from rifle fire. In difficult terrains, such as mountains or tracks with tight curves, the hook could get stuck or break, so it was common to complement it with explosive charges. The later versions reinforced the main arm with steel plates and a damping system that reduced the damage to the wagon. The Schienenwulf was normally pulled by diesel locomotives, WR 360 CL12, fabricated specially for the Wehrmacht. These machines of robust design allowed to maintain the constant speed necessary for the hook to do its work. Its effectiveness was so great that even the Soviet and Polish armies developed their own versions with a similar functioning. However, when the retreats accelerated towards 1944 and 1945, the Germans had to abandon many of these wagons, since they could not operate with the rapidity that the situation demanded. Some of these units survived and today are conserved in railway museums in Eastern Europe. In several photographs of the era, they can be seen functioning in places like Itri, in Italy, or in different points of Ukraine. The images clearly show how the enormous metallic hook dug into the center of the track and lifted the wooden sleepers, leaving behind it a trail of complete destruction. Its purpose was simple, but its effect was devastating. Panzerkampfwagen 8 Maus, the colossus that came to exist. The Panzerkampfwagen 8 Maus was the heaviest operative tank fabricated during the Second World War. The Porsche company initiated its development in 1942 by direct order of Hitler, who desired an armored vehicle capable of resisting any Allied cannon. Unlike other theoretical projects, this model was built physically in the facilities of Krupp in Essen and came to complete 2 units before the collapse of the Third Reich. The first chassis, denominated VIII, was ready at the end of 1943, while the second, V2, was assembled shortly after with all the combat systems installed. Both were assembled with a level of armor and power that surpassed any existing tank in the world. The original design contemplated a total weight of 188 tons. Its hull had a frontal thickness of 220 millimeters, the sides of 180 and the rear part of 150. The turret was even more robust, with a layer of armor of up to 240 mm on its frontal part. That assembly allowed it to withstand direct impacts from the most powerful anti-tank cannons of the era. Its length reached 10 meters, and its width was around 3.5. The profile, despite the height of almost 4 meters, offered a silhouette of straight lines and an inclined surface to deflect projectiles. The main armament was composed of a cannon of 128 mm KWK-44L55, the same that equipped the Jagdtiger tank destroyer, and a secondary coaxial weapon of 75 mm KWK-44L36,6. To this was added an MG-34 machine gun for close defense. The munitions were stored in protected compartments, and the reloading required a precise coordination of several members of the crew. The assembly moved thanks to a Daimler-Benz MB 517 diesel engine of 1,200 horses, connected to an electrical system designed by Porsche. The engine propelled a generator that fed 2 independent electric motors, one for each track. This configuration, although complex, offered a smooth movement and a very precise turning control for a vehicle of that size. During the tests in Kummersdorf and Böblingen, the Maus demonstrated that it could move with relative stability at speeds close to 20 km per hour on a firm surface. However, its enormous mass limited any type of logistical transport. No bridges existed capable of supporting it, so it had to cross rivers by means of an improvised snorkel system. One of the prototypes was tested in wading maneuvers with partial success, while the other served to adjust the turret and calibrate the armament. Despite the acceptable results in a controlled field, the tank was too big for real operations. The reports of the Wehrmacht from the end of 1944 recorded that Krupp had completed the fabrication of 6 additional unassembled chassis, which were destroyed by the German troops to avoid their capture. Only the 2 prototypes remained operative at the end of the conflict. In April of 1945, when the Red Army reached the zone of Kummersdorf, the V1 was found without a turret, and the V2 partially damaged. The Soviet technicians combined the pieces of both to obtain a single functional example, which was then transferred to the Soviet Union for its evaluation. In 1946, the reconstructed Maus was taken to the testing ground of Kubinka, where Soviet engineers analyzed its internal design, the electrical propulsion systems, and the structure of the armor. The report of the specialists confirmed that the vehicle was practically invulnerable to the standard anti-tank armament of the era, but at the same time inefficient due to its slowness and fuel consumption. The calculations showed that it needed several hundred liters of diesel for every 10 kilometers traveled. Even so, the technical study served to understand the degree of sophistication reached by the German heavy industry during the last years of the war. The only complete surviving example was conserved by the Kubinka Tank Museum, where it remains on exhibition. Its structure combines the turret of the V1 prototype and the hull of the V2, assembled after the Soviet occupation. Throughout the following decades, the Maus became a reference piece for researchers and military historians interested in the development of extreme armored vehicles. BMW RR75, the companion of the front. During the Second World War, the BMW R75 became one of the most versatile machines of the German army. Fabricated by BMW Motorrad from 1941, it combined a robust motorcycle with a sidecar that propelled the 3 wheels at the same time. This configuration gave it stability on snow, mud or destroyed roads, something essential for the rapid transport of troops and messages on the combat fronts. The model emerged by direct commission of the Wehrmacht, which was looking for a motorcycle with greater autonomy and resistance than those employed during the First World War. The engineers of BMW started from the civil design R71, launched in 1938, and modified it with a boxer engine of 745 cubic centimeters, double traction, and a reinforced gearbox. In parallel, the Zündap company developed the KS 750, almost identical in structure and power. With time, both companies agreed to unify parts and components, which simplified the repair in the middle of a campaign. The 2-cylinder engine, air-cooled, delivered 26 horses of force and allowed to reach some 95 km per hour. The transmission system included 4 speeds plus a reduction gear, useful for irregular terrains. With a moderate consumption and a gasoline tank that yielded close to 250 kilometers, it was perfect for patrol, liaison or exploration missions. The sidecar was not a simple addition. It had its own axle connected to the rear wheel, which granted total traction to the assembly. It also had an independent brake and a differential lock mechanism that maintained stability even in tight turns or soft surfaces. In that lateral compartment travelled a companion who could operate an MG-34 or MG-42 machine gun mounted on a rotating support. Thanks to that combination of mobility and firepower, the R-75 was used as a light combat vehicle, not only as a means of transport. The chassis, fabricated with steel tubes, offered great rigidity, and the telescopic front suspension improved the driving. The wide tyres resisted wear on hard terrains and could support without difficulty more than 270 kilos of cargo, in addition to the 2 crew members. In the design, practical details were taken care of. The windshield of the sidecar protected the gunner, and on the exterior were placed compartments for tools, ammunition or spare parts. Some versions had supports for fuel cans or skis, and those that operated in the north of Africa incorporated additional air filters and modified radiators to withstand the extreme heat. Everything in the R-75 was thought to function under any condition: cold, sand, mud or snow. Between 1941 and 1944, around 16,500 units were built. After the conflict, many continued in civil use and served as a base for the Soviet models Ural and Dnepr, which conserved the original design almost without changes. The BMW R-75 remained as one of the most recognizable mechanical symbols of that era, a war motorcycle that united power, resistance and German precision in a single vehicle. Thus ends the tour of the 20 most extraordinary vehicles conceived during the Third Reich, creations where innovation and madness were mixed in equal parts. Each one of these machines reveals how science and technique, when they are subordinated to power, can reach astonishing achievements and terrible consequences. Some of them anticipated the future of engineering, others remained buried as a reminder of a time in which human ambition imposed itself over reason.